Saxon Advanced Mathematics, Lesson 96. The first and most important part of this lesson is about double angle identities. We're going to practice using them in identity type problems, our new double angle identities. But that's kind of a mysterious statement, because when we worked on those double angle identities, what I told you was that we weren't going to memorize them straight out. We were going to learn to derive them from the sum identities, right? We take the sum identities and we use those to calculate the double angles. The double angle identities, there was one, the sine of 2x has one form, and it can be any letter there. And the cosine of 2x has three forms. Remember doing this now? And what we're going to do is we're going to continue on with this notion that we don't have to write these double angle identities out every time. We're going to keep our sum identities really close at hand, and we're going to use those and do the conversion in our head. And I'll show you what I mean as we go. And I think you'll feel really confident in your brain power. 96.1, there are only two. Show, and then here's our identity. Okay, so here's what we've got to start with. This is where we want to end up, right? Now, as I look at this, I go, well, look, that's got a double angle identity in it right there. That gives me a pretty good idea that somewhere along the line here, I'm going to be needing to use a double angle identity to create that. I see that it's sine of 2x. Sine of 2x, it only has one form, so I'm happy about that. At least it'll be simpler. Okay, the first thing we need to do is square this bad boy. So what I'm going to do is I'm going to write another one down here. And then I'm going to multiply these two to get the square, right? So this will be sine squared x plus sine x cosine of x. She's done. Her turn to dance. We go up over here. Again, sine x cosine of x plus cosine squared x. Okay, so let's take a look at what we've got here. At this point, this is the whole left side, right? I'm leaving that alone, but I've got everything engaged. There are no other pieces. Sine squared x plus, then this will be 2 sine x cosine x plus cosine squared x. Okay, so I'm just adding my multiplication. So this is what I get when I square that. Now, the first thing I notice is that these two go together to make a Pythagorean little baby doll, right? Because we know, let me get my Pythagorean just to show you. Sine squared plus cosine squared equals 1. Oh, so I can change, I'll just write that here. Sine squared x or theta, it doesn't matter what letters you use, plus cosine squared x equals 1, right? So this changes to, these two disappear, I have 1 plus 2 sine x cosine x. Okay, I compare this to this and I go, okay, I've got the 1 plus, that looks good. Now I have to figure out how to turn this into this. And this is when I go, you know what? I better look at my sum identities to see if there's some way I can get this to work. So here I am. Here are my sum identities. And I want to look at this sine. Now, this is when I have an A and a B. I have to mentally adjust myself for the fact that it's A plus A, right? That's how we create the double angle identities is we change this into both A's. So this would be sine A cosine A plus sine A cosine A. That would be 2 sine A cosine A. And that's exactly what we have here. Only we have x's instead of a's, whatever, right? So what I can do is I can use my notes here to recreate the double angle identity for sine. And let me, hang on, I just want to grab a piece of paper so I can do it while you're looking. Okay, so there's the angle, or there's the identity we want to use. I'm going to change it to the sine of a plus a, right? That's our little trick. And then that gives me sine a cosine a plus sine a cosine a, right? Because the b's disappear. And these are exactly the same. So we can write that the sine of 2a equals 2 times the sine of a cosine of a. This is the double angle identity we need in this problem. And that's how we can go from this, which we memorized, into this, which we do not memorize, but we can easily bring it to the surface of our brains. Once you get the hang of these, you don't even have to write it down. Maybe you're even at that point right now. I wrote it down to make sure you understood. But this is how we take the sum for sine, we switch it up so that it's the same angle, bring that change across, and then simplify it. If you can work this in your head, hot diggity, that's really good. Okay, so now what we're going to do is we're going to use this in this problem. I'm going to write it right here. We said the sine of 2, we said a, but I'll change it to x, equals 2 times the sine of x times the cosine of x, right? That's what my paper says right here. I just copied that down. I changed the x's to a's, or the a's to x's rather, so it would match to the problem, but it doesn't matter. Now, that means I can change this according to this identity, and I have 1 plus the sine of 2x. I just wrote it wrong, right? It's this. This now equals that, and we did it. Okay, so we used a Pythagorean identity, and then we used a double angle identity that we derived in our heads / on paper from our sum and difference identities. That's the magic of how more advanced identities work. Okay, we have one more problem that's going to have a similar vibe to it. It's 96.2. Show, oh my gosh, it's really big. Oh, I forgot the X. There's a double angle right there, equals 1. What? All right. Okay, I want to tackle that numerator first. And what I notice is it's got that classic a squared minus b squared, that difference of two squares pattern. And we know how to factor that. A plus b, a minus b. It doesn't matter whether the plus is first or the minus is first, just as long as you have both. Now, when I find the roots of both of these, I can see it's going to be cosine squared, right? Because this is to the 4th power. So when I break it down, I'll have squares here. So this will become cosine squared x minus sine squared x, and then the plus. Cosine squared x plus sine squared x. I did the classic me thing of here I wrote the plus and the minus, and then here I wrote minus and plus. Order doesn't matter as long as you have one of each. Okay, and then this whole thing is over cosine of 2x. Okay, I see a couple things that I want to do. When I see this, once again, I think of my little Pythagorean sunshine. Where are you? I see this one. Sine squared plus cosine squared equals 1. This can all drop off and go to 1, right? Because I always like to write it sine squared plus cosine squared equals 1. So that means this will all go to 1. This I'm going to leave. Let's look at our double angle identities for cosine and see if we can derive. We'll look at our sum angles for cosine and see if we can derive the double angle, right? We memorize the sums, we derive the double angles. Now, cosine is tricky because there's 3 forms of cosine, but we'll just start with the first one and go from there. All right, I'm folding that sine business away so we don't have to look at it. There's the cosine sum identity. So that's what we're going to use, and we're going to change it to a plus a. So that'll be cosine a minus sine a. And that means that the cosine of 2a equals, that's a square, minus sine squared a. Okay, there's our first form. Let's go ahead and derive the other 2 forms just to practice doing it. We remember that we're going to use this Pythagorean, and we're going to rearrange it and substitute it in here. So first, I'm going to subtract the sine squared a, 1, and it'll become cosine of 2a squared a equals 1 minus sine squared a. And then the third part of it, I'll do it the other way. I'll subtract the other one, right? I'll say sine squared a equals 1 minus cosine squared a. Now, to get the second form of this, I'm going to plug this in right here. So I'll have cosine of 2a equals, instead of this, I'll have this, 1 minus, and then I'll have 2 of those, won't I? So I'm just going to go ahead and write the 2. Sine squared a. I remember that form 2 is pretty straightforward. It's 3 that has the weird minus signs I have to be careful with. All right, so that's my second form of cosine double angle. And now let's do the third one. Cosine of 2a equals, okay, I'm taking this, I'm leaving cosine, but I'm putting this one in down here, right? This minus, here, I'll go ahead and put it in. Cosine, I'll do it in 2 steps. Minus 1 minus cosine squared a, right? I put this one in for the second form. I put this one in for the third form. Now I just have to straighten out these minuses. This will make this minus and this plus. So the cosine of 2a equals 2 cosine 2a minus 1. So there's our third form. That's actually the third form there, right? Now we go back and figure out which, this is all from that previous lesson where we learned how to do double angles. Now what we're doing is we're trying to figure out which one of these 3 cosine double angles we would like to have in here. And we need this to cancel out to 1. We've already canceled this much to 1, right? With our Pythagorean, that's gone to 1. So what would be really cool is if one of these forms of the cosine double angle was exactly equal to this, then we would cancel top and down. So let's see if any of our double angle identities equals that. And here it is right here. It's the first form, which I'll be honest with you, I knew, but I just made us do forms 2 and 3 for the practice. Okay, so we can substitute where we have this. We can write cosine of 2a. No, the other way around. We've already got the double angle, right? So we want to put this in. So we want to say, I'll use a different color. The cosine of 2, I'll change the a to an x so that it matches. It's cosine squared minus sine squared. That's our double angle. And we're going to put this in that place. So, ready? This stays cosine squared x minus sine squared x. This already turned into a 1 thanks to our Pythagorean. That's why it's an orange. This denominator, we're going to change to this, which is the double angle cosine first form. That's the one we like. And the reason we like it is because it looks exactly like the numerator. And now this cancels and it equals 1. And we did it. All right. So in the first example, we used the sine double angle. And we developed it here. Then in the second problem, we had to do the cosine double angle. And at first, we weren't sure which form we were going to need. So we developed 1, 2, 3 forms of it, and then looked to see which one made the most sense in our problem. That is lesson 96. That is a wrap for our winter section of study. That means, looking for my schedule, that means we are midterm ready. That means that you'll finish this homework, and the next Monday, here we go. Here's where we're at. We finished 95, we finished 96. Next Monday, March 28th, I will drop you a review video. I'll tell you which lessons to study. I'll remind you about formulas, and I'll remind you about the identities that we need to study on the test. Remember, on the test, I'm going to give you a blank version of this form. Winter midterm identity page, answer key. Ooh, that looks important, doesn't it? Okay, so these are the different functions that you'll need to know on the test. Once you fill this in, you can use it on the test. The test will be Wednesday to Thursday. Same process as usual. I'll drop it at your house on Wednesday, 1-ish, and then I'll come back on Thursday, probably between 2 and 3, and pick it up from you. I'll grade it. I'll tell you your score. You will throw your math book under your bed and forget you ever met me for spring break. And then on Monday, April 11th, you don't have to do any homework over spring break. This is when the new lesson will come out. Okay? So if you're following me on YouTube and you're following along with our schedule, April 11th is when you can look for a new lesson. If you would like to take the same test that I give to my local students, just email me. My email's in the About page. Just email me and I'll send you a PDF of the test and you can take it. I'll send you the answer key too. All right? Once we complete the test, we'll come back. Everybody will complete one more week so that we finish through lesson 100. That's the part where I lied before. I said we were going to go right to our AccuPlacer review after spring break. Sorry, I lied. We have 4 more lessons. We'll get to 100. Then, if you're preparing for college entrance we'll change gears and we'll do those keys to algebra as a review. If you don't want to do a review and you just want to keep going and finish the textbook, I will do that as well. So those lessons will continue to post for anyone who wants to use them up through 120. I'm done. Goodbye.